Hi everyone. What we're looking at here is the exercises I put up on Google Classroom, and they're all what we call separable equations, differential equations. And what we mean by that is that what we're able to do, we'll notice that we have an implicit function here with x and y, so x squared y, x y squared. And because when they're in that separable form, usually that's because there's got the multiplication between them, and we can break them apart and put all the y's on one side and put everything in terms of x on the other side. So that's the idea of a separable equation. So starting with that function, all we do is divide by the y squared on both sides, and we're going to multiply by the dx on both sides. So now we're in a form that we can start to integrate both sides with respect to those variables. Bit like we did with the differentiation using substitution. I just have the variables on either side, and I differentiate with respect to both variables on those sides. So once we've got all the x's on one side and the y's on one side, all we need to do is integrate both sides. So y squared is it's 1 on y squared, which is y to the power of minus 2. That'll give us negative y to the power of minus 1. And x becomes x squared on 2. Don't forget your plus the constant. Now, how you leave it, well, when Alan was doing the work the other day, he seemed to be happy to leave it in this form. But you can start to manipulate it down. All I've done is multiply it by the negative, and then taking the reciprocal of both sides to get rid of the minus 1 there, and have it 1 over x squared plus 2 plus c on the right hand side. But that's in the explicit form. So explicitly would be y is equal to a function. Implicitly was where we just had x and y's together, where y is supposedly a value, some function of x. Let's have a look at another example. This time another separable equation. So x and e to the minus y, which again you could write that as x over e to the y. So when we simplify this, well, the e to the y just gets multiplied on both sides, and the dx gets multiplied on both sides, and then we integrate. So the integral here is not too hard. Sometimes they're going to be a lot harder, but this is a nice little integral there. So e to the y integrates to e to the y, and x integrates to x squared on 2 plus the constant. Again, we can check with Alan to make sure he's happy with that, or we can put it in pretty simply into an explicit form by just taking the definition of a logarithm on this side. So e to the y, and then the log that can become y, and this will work out as a log function of x squared plus 2 on c.